Yeah. Another activity we have planned those competitions for students. Another activities we had planned and we have executed is like showing acid writing and poetry writing. This was also conducted during this lockdown period, and now we also have arranged this national webinar. Okay, Dr. Shankar sir has joined us. Welcome, Dr. Shankar sir. Shankar sir, good morning. Okay. And this is the message by our students regarding corona epidemic. जो साथ दे सारा इंडिया, फिर मुस्कुराएगा इंडिया, फिर जीत जाएगा इंडिया. Stay home, stay safe, stay healthy. Thank you. So this was a beautiful message created by our college students. And here I have coined a very good, beautiful, you can say term or logo for the theme of our seminar: working together for sustainable, self-sufficient, and self-reliant Bharat. So our aim is to become self-sustainable. We need to become self-sufficient, and we need to go self-reliant. Today we have our esteemed panel members with us. Dr. Venkateshwarlu will join shortly. Dr. Ravi Shankar will join in the next session. Dr. Shankar sir has already joined with us. I'll introduce him. Dr. Hari Babu sir, Dr. Arpita Sharma ma'am, and Dr. Mangesh Shirdankar sir. They will also join. Dr. Shirdankar sir has joined now. Other expert panel members are Dr. Ambekar Eknath, former Director General of NACA, Dr. Hukum Singh sir, former Dean of Ratnagiri Fisheries College, Dr. Krishnan, Principal Scientist, Social Sciences Division, Mumbai, Dr. D.I. Pathan, Professor, College of Fisheries, Ratnagiri, Dr. Nasimha Murthy, Principal Scientist, CIFT, Dr. Amjad Balange, Senior Scientist, CIFE Mumbai, Dr. S.V. Patil, Sandesh V. Patil, Associate Professor, College of Fisheries, Ratnagiri. So these are all our esteemed panel members. Excuse me. Hello, sir. Good morning. Link મોકલાવી તમને છે. લિંક મોકલાવી છે. મેલ ઈમેલ. હું પાછો મોકલાવું થોડી વાર. So, and then other experts are Dr. Ashish Kumar Jha, Dr. Gohar Wani, Dr. Ashraf Rathar, Dr. Smith Lende, and Dr. Naveen Kumar sir. So this is it regarding introduction of my institute. Okay, stop share. Hello, Dr. Shankar sir. Good morning, sir.
Morning.
How are you, sir?
Earphone
better. This is fine. Is it audible?
Yes, it is audible, sir.
Okay. Fine, sir. I speak loud.
Yeah, we'll wait for a few more minutes because we have.
Oh, yeah. That's right.
I need to send emails to some people because they are not able to join now. Please wait few more moments, sir. Please.
Yeah. Fine.
ನಿಮಗೆ PPT
PPT ಆಪರೇಟ್ ಮಾಡ್ತಾರೆ.
ನೀವು ನೋಡೋದಾ?
ನಾನು ನೋಡಕ್ಕೆ ಶಾರ್ಕ್ ಇದರಲ್ಲಿ ಇದೆ PPT.
ಅಲ್ಲ ಇಲ್ಲೇ ಇದೆ.
ಡೌನ್ಲೋಡ್ ಮಾಡಿದ್ವಿ, ಇವ್ರು ಕಳಿಸಿದ್ಲ
ಅದೇ ಸೈಡಲ್ಲಿ ಬರುತ್ತಾ
ಅದು? ಹಾ,
ಅಲ್ಲ ಅವ್ರು ಮಾಡಲ್ಲ, ಅವ್ರಿಗೆ ಹೇಳಿದ್ದೀನಿ.
ನಿಮಗೆ ರೆಫರೆನ್ಸ್ ನೋಡಕ್ಕೆ
ಬೇಕು ಇದು ಸೈಡಲ್ಲಿ ಇರಲಿ, ಸೊ ದಟ್ ಐ ಕ್ಯಾನ್ ಟೆಲ್ ದೆಮ್.
ના 11 નહીં, 11:30 તમારું કામ પતાવી દે એટલે 2 વાગે આવતા હોય તો વાંધો નહીં. એમાં કઈ 11:30 જાય તો ચાલે. પણ 11 થી 2 કામ કરીને તો એમ નહીં. ના ના
Good morning, sir. Desai sir, namaskar.
Hello, all the panelists. Kindly mute your mic, please. All the panelists, I would request you to please mute your mic. Only Dr. Shankar sir will speak, and so that we will be able to hear him nicely. Okay, fine. Let me.
Now, before that, can you hear that one dum-dum sound here?
Okay, sir. That is not a.
Are you hearing one extra sound here in the building?
Yeah.
Going on repair.
Okay, sir.
ಈ ಡಿಸ್ಟೆನ್ಸ್ ಕ್ಲಿಯರ್ ಆಗಿ ಕೇಳುತ್ತೆ.
ಆ ಕಡೆ
Dear participants, let me please introduce Dr. Shankar sir. Dear panel members, please kindly mute yourself. Only Shankar sir will be speaking today. We'll listen to him. People are aware that Dr. Shankar sir has served in the various capacities, and he has performed as a teacher, as a researcher, and as an extension author in his illustrious career. His major area of research is biotechnology and fish and shellfish health management. He is considered to be one of the finest and strongest pillars of health management of aquatic organisms in India. He established a disease diagnostic center with funding support from BFID UK and Government of India, and provided diagnostic service and tips on health management of fish and shellfish to farmers in the country, right from 1993 up to 2003. He has played a central role in transferring the technology such as Rapidot kits or the kits related with detection of white spot virus syndrome. Apart from this, he has developed rapid farmer level MAB-based flow-through immunoid kits for detection of EUS fungus, Aromas hydrophila, Vibrio, oxytetracycline, and other such novel parameters. He has published 89 research papers in peer-reviewed international and national journals. He has served as the chairman, ICR 5th Dean's Committee, Fisheries, 2014. We are very much well versed with this ICR 5th Dean's Committee recommendations, and what we are teaching today for our undergraduate students. The syllabus developed by that committee is followed all across SAUs in India, or across all the fisheries colleges in India. So there, Sir was the chairman of that particular 5th Dean's Committee. And he is a recipient of many prestigious awards, such as Bharat Ratna Dr. C. Subramaniam Award for Outstanding Teachers, Biotechnology Product and Process Award, PFGF Best Teacher Award, to name a few. And he is also a fellow of National Academy of Agricultural Sciences, New Delhi. So we have a very big personality with us, and we will listen to him today. We are very much eager to listen to him. So welcome Dr. Shankar sir for his session today now. Dr. Shankar sir, are you ready?
Yes. Yeah.
Okay. Shall I?
It's clear. Can you hear me? Hello.
Yes, sir. Shall I start?
Shall I start?
Yeah. Okay.
Can I start?
Let me show you a presentation, sir, from here.
Yeah. Right.
Okay.
Shall we go?
Yes, sir, you may please start.
Yeah. Okay. Very good morning, ladies and gentlemen. First of all, appreciation and compliment to Junagadh Agriculture University for initiating this webinar on the challenges in fisheries with reference to COVID-19. When everyone, the whole world is thinking about the future, we have really made use of the adversary for the advantage to prepare the people in fisheries to face the challenge. One thing I further appreciate here is the participation of students. Normally, their number is low whenever we organize the usual conferences for various reasons. I find yesterday their number is it's a good number. In fact, this very asset of our academy, Fisheries Academy, is very well encouraged, and they are the future pillars of fisheries in India. Now, when the organizers called me and gave me an option to choose a topic in my area, health management, it which is appropriate for the situation, I chose biosecurity because this is the one which you have been hearing for the last 3 months, human biosecurity from COVID-19. Start any video, audio visuals, talk to anyone over phone, meet occasionally because of the lockdown, any person, he talks of biosecurity and the COVID. It is in fact ringing in our ears for the last 3 months. I thought biosecurity in aquaculture or for aquaculture would be an appropriate subject. Now, biosecurity is a buzzword in any health management, be it human, animal, and it is rather a new area for aquaculture. That's why I chose this area. Now, why it is new for aquaculture? Aquaculture itself is new. Fish aquaculture, maybe modern fish aquaculture is 40, 50 years old. And our shrimp culture is further, still younger. It's about 25 years old. And we have a large number of diseases in this short span already. But unfortunately, the health management is inadequate to deal with the situation for various reasons, which I'll deal later. That's why aquaculture is very, very important. I always think to make understand the stakeholders, starting from a farm, a manager, a local level, taluka level personnel, fishes personnel, and the district level personnel, state level personnel, to the top in Delhi, the message has to go well. I said we introduced biosecurity in aquaculture only in the recent past, say 10 years, but the message has not gone to many stakeholders. I thought now people have understood very well the biosecurity because of the COVID-19. I thought this is an occasion to hammer it out so that we send across a good message on biosecurity in aquaculture, which will be applied, understand well in future. Now, what is biosecurity? Can I go to the next slide, please? Can you hear me? Hello?
Yes, sir. You are clear. Sir. You are audible, sir.
Yeah, please go to the next slide.
Okay, sir. Okay. Wait, sir. It's not working. Yeah.
Biosecurity is protection of aquaculture industry through establishment of safeguards to fish health, fish rearing facilities, and the environment. It's a broad definition rather. It is protection of aquaculture industry. First is fish health and also the rearing facilities. Safeguard the rearing facilities from any pathogen. Because once a pathogen gets established in any facilities, again, it's difficult to manage it. And lastly, one should be aware of the environment. The environment around us is very important irrespective of the industry we are running, because once the environment goes bad, it is just like white spot virus. I don't know whether you are aware of it. It is there in our farm. It's there in adjacent waters. It is there in the deep sea. 30 to 40% of the brood often come getting infected with white spot virus. See how we have damaged the environment because of our farming activities. So biosecurity is a broader term. It includes new pathogens, prevention of new pathogens, eradication or control of pathogens already present, and simple, fish health from infectious and non-infectious. When I say non-infectious, there are a lot of biotoxins around us. Algal biotoxin, that is blue-green algae, dinoflagellates, they also come under the biosecurity. Okay, we will move on to the next slide, please. Before getting into biotechnology, let us have a look at the aquaculture today, superficially. Although Dr. Haribabu gave a very good presentation yesterday, I enjoyed it. He is really a field scientist, Dr. Haribabu. I will touch upon superficially the aquaculture today with respect to biosecurity. It's one of the fastest growing food producing industry in the world, growing at 67%, including India. and it's almost meeting more than 50% of the world fish production. In another 10, 15 years, probably it might reach to 70 to 80% because the natural catch is getting plateau. We need fish. And it is increasing in area. Large extent of water bodies are brought into aquaculture. Very interesting and also disturbing, but it's very necessary also. That is aquaculture in non-conventional waters. When I say this, people might wonder what is this. A lot of saline soils are brought into aquaculture these days. Most of you are aware, I'm sure. There are large extent of saline soils, that is agriculture fertile soils mismanaged by excessive irrigation have turned barren because of the leaching of the soil, salt, and it's unsuitable for agriculture, but can be used for aquaculture. Lot of such area, it's around about 8.5 million hectares in Karnataka, Maharashtra, and Haryana. They are brought under aquaculture. Now, why I'm stressing this is, you are moving a host from its original habitat to an unconventional area, and a host invariably has its own set of pathogens. Often under this circumstance, pathogens might become virulent, or sometimes they behave very badly, become virulent and causing epidemic disproportion. So there are very many examples when a pathogen is disturbed when it's moved out of its natural habitat. Further, there's a lot of increasing activity, movement of seed, brood, products across national, international borders, and also aquarium industry is growing like anything. That's the one which is moving pathogens from one place to another, one region to another, one country to another. Okay. And beside this, aquaculture, we use large number of species from different phyla. Fishes, that's lower vertebrates, invertebrates like shrimp and mollusks. So it's not, we are not restricting one phyla like husband on the land, animal husbandry. Maybe we have within the vertebrates, you have birds and other mammals, primates. Okay? But in aquaculture, we are dealing with large number of species from different phyla. So this is the overall picture of aquaculture today in India or elsewhere in Asia from biosecurity point of view. Please move on to the next slide, please. Next slide. Internet slow.
So this is the next slide.
Yeah, okay, good. Health status of aquaculture. After understanding superficially aquaculture today, what is the health status of aquaculture? I said it's a young industry. Even though it's young, incidence of disease in aquaculture. If you look at the last 50 years history, there are a large number of diseases have come up in fish as well as crustacean. And the number of disease in crustaceans, 15 to 20 viruses have cropped up in the last 15, 20 years. So this is a special scenario compared to vertebrates on the land. So there is increasing incidence of disease, and mostly it is parasites. They constitute majority, I should say, followed by bacteria, fungi. This is the incidence I'm talking about in percentage. Viruses, although they are small, 2.7%, the damage caused by them is much more compared to other bacteria or fungi. But remember, parasites are the silent killers. We have not estimated the damage caused by parasite yet, like in the developed countries. They have a clear picture how much a parasite causes loss in economy. Apart from this, apart from the existing diseases, we have emerging new diseases. Every year there are new diseases are cropping up. Of late, the last 1 month, I read somewhere, I think a new viral disease has cropped up in China, again in shrimp culture. So it's a continuous process because these are very delicate animals. They're not sturdy animals. So these are the infectious disease. Among the non-infectious disease, you know well, some of the biotoxins in Ciguatera, scombroid fishes. So these are the biotoxins produced by dinoflagellates, blue-green algae. They also have to be taken care when you talk about biosecurity. Now, OIE, that is the World Animal Health Organization, has listed 8 serious fish pathogens in the world I am talking about, and 10 shrimp pathogens. Once there are several pathogens around the world. It is serious in some places, it's not serious in some places. In some places, they are just sitting there. But it is the World Health Organization which finally concludes that it's a serious pathogen and it has to be dealt seriously. Otherwise, it will damage. So they are the ultimate, rather, World Animal Health Organization to classify a pathogen. Now, as I said, these pathogens are causing heavy loss due to mass mortality. Not necessarily it should be mass mortality. As I said, parasites are the quiet killers with chronic disease, poor growth, ultimately reflects in low production. Overall, I should say disease are the single most heard for aquaculture production. In a short history, we have witnessed several diseases, devastating diseases, particularly viral diseases. We'll go to the next slide, please. Next slide, please.
This is next slide, please.
Yeah. Now, it's very important to understand the species used in aquaculture. I said they belong to 3 different phyla altogether. To understand the seriousness of biosecurity, you have to understand the nature of species we use. They are cold-blooded lower vertebrates and invertebrates in simple. These are the animals you are playing with in aquaculture, very delicate animals, cold-blooded lower vertebrates and invertebrates. They have a poor immunity. Most of these lower animals have poor immunity. Most of it is non-specific. Now, if you look at the evolutionary ladder from lower to higher animals, there is a gradual increase in immune system. It's more of non-specific immune system down below, and when you move up, it is specific immunity. That is, let's say human beings, specific memory, specificity, antibody production of different sort, and the protection. That sort of luxury is not available down below the evolution. Okay. Now let us look at the fish in particular. The fish immune system has specificity and memory. This is very, very important. It's like fish encounters a pathogen today, a virus today. It produces antibody, and a part of its cells, memory cells, remember the incident. And when the virus strikes again after 3 or 4 months or a year later, these memory cells react in a bigger way, producing antibody and neutralizing the virus. Okay. In simple, fish has specificity and memory component in its immune system, the very basis for vaccination. The vaccination depends on specificity to an antigen and the memory. Okay. But unfortunately, immunity is short-lived. Like take an example, human beings, a smallpox, you're all vaccinated against smallpox. It's a lifelong, protection. Whereas in case of fish, it is short-lived. It's not that, although fish live for a shorter period, but in that, this protection is for a shorter period. And it's not as well developed as in higher vertebrates. Now, I say this because fish have antibodies. We say they are IgM-like. They are not IgM, IgM-like. Okay, tetramer molecules, glycoprotein molecules. Whereas, look at the highly developed animals. Say in mammals, we have IgM, antibodies, IgM, IgG, IgA, IgD. These are the major 4 classes of antibodies. And in IgG, which is a permanent asset, we have IgG1, G2, G2A, G2B, G3. See, as I said, when we move up, the antibody class also, there's a lot of vast expansion. That's an index of development. Now, that's not the end of the story. I said fish immune system is not developed as in higher animals. But again, among the fishes, there's a variation in immunity. Okay, like we have, let us say, we have carps, we have perches, we have catfishes, we have salmonids. Perches have a better evolved immune system. They are quite strong. Tilapia, for example, from Africa. Next is carps. Carps, although not as developed as in tilapia, but they have a well-developed system, much better than what we have in salmonids or other catfish. So there's a variation among the immunity among the various lower vertebrates. That's fish. So overall, we can develop vaccine for fish. Although we don't have many vaccines around for bacteria or virus, we do have developed some vaccines. In India, not many, but in the world over, if you consider in advanced countries, there are a good number of both viral and bacterial vaccines. Next slide, please. Can you move the slide, please? Yeah. Now, I talked about the fish, the immune system in fish. It is less developed compared to mammals or higher vertebrates. Look at the crustaceans, which we are fond of. The whole aquaculture, brackish water aquaculture is thriving on crustaceans. As such, till today, we don't have any evidence of specificity or memory in the immune system. Okay, so it means vaccine cannot be developed. I said in the beginning, specificity and memory is the key component basis for vaccination. So as such, we cannot develop any vaccine for shrimp. At best, we can immunostimulate them. Immunostimulation, that is non-specific, it stimulates the non-specific immune system of the shrimp, but you'll have to provide the antigen very often to keep it stimulating. Overall, consider the immune level of fish and crustacean. We are dealing with very delicate and sensitive animals in aquaculture. I go back to Dr. Haribabu's talk yesterday. It's a high-risk industry, particularly shrimp. You have to be very, very careful. You cannot play with. Like, if you really visit the field, you'll understand the way sometimes things are going on. Additionally, I said the fish and crustacean immune system is low compared to higher vertebrate. Additionally, no other land animals gets influenced as much as fish with the environment. Environment plays a key role. It is the very medium in which fish and crustacean lay. Its temperature, oxygen, influence, metabolic activity, physiology, stress, then leading to disease. Like most of the pathologists, those who have studied fish disease, they understand my talk here. We always explain the disease development using 3 circles, interaction of 3 circles. One is the host, another is the environment, then the pathogen. How well these 3 are interplaying to develop a disease. For example, your host is doing wonderful. You are taking care of the host, feeding it well, it is healthy, and the environment is good, very, like less pollution, more oxygen, temperature, of course, you have no control, environment well. Then the pathogen is kept at bay. The 3 circles are at a distance. So the intersection where you find the disease is very, very small. On the other hand, you are not taking care of the host well, and the environment, there is a problem, pathogen takes an upper hand and it comes closer, interact, the intervening D expands, you have more disease in the system. Okay, so with this background, we will go to the next slide, please. Yes, aquaculture status, health status, the status of health management. Let us see. Now, what is the status? I said it's an young industry. The industry itself in Asia, which constitutes about 80% of the world, is young. It's shrimp is about 15 to 20, fish about 40 to 50 years old. Modern aquaculture I'm talking about. So there are not enough preventive measures. How many vaccines we have in India today for fish? Of course, for shrimp, you cannot develop any vaccine. But how many we have for fish? People are working, but off late, I mean, till this point, we don't have a workable vaccine. People are trying. Maybe very soon we may have some vaccines. And not enough preventive fine for fish, although we can develop vaccine, but for shrimp, as said, we cannot develop vaccine because it's one side. They don't have a system which can adapt to the vaccine. No specificity and memory. So we will have to avoid the pathogen. We have to prevent the pathogen to the system. Next, curative measures. How many, I mean, what is the status of curative measures? Blindly, we are copying from animal husbandry. The use of drugs, antibiotics, many chemicals. Some of the chemicals are, I should say, abused. Okay, treatment is based mainly at the moment, knowledge and experience from warm-blooded vertebrates, from the veterinary system. And remember, they are warm-blooded. We have the cold-blooded vertebrates. Therefore, prevention and avoidance of the pathogen is the best strategy. Still, we are working on vaccine, we are working on the drugs, but we are a long way to go. At the moment, we don't have any, well-developed system. That's why avoid the pathogen through water, brood, seed, equipment, animals, working personnel, fish food organism. So whatever you see or whatever you imagine, look at the pathogen source and try to avoid it. And it is possible, although it's difficult. Okay, in simple, when you say avoid, it means we need for aquaculture a biosecurity of very high order. It's much, much different from what you find for the land animals, husbandry. I should say it's an additional biosecurity. Okay, we'll move on to the next one, please. I would like to draw a parallel between biosecurity of two animal systems. This will explain well, understand better. The latest human biosecurity of human from COVID-19 and the shrimp from white spot virus, these two systems. Now, we have COVID around. What are the biosecurity contingency measures we have at the moment? Everyone is hearing, everyone is reading. You are aware of it, like lockdown, restricted movement, means pathogen is restricted. Its movement along the host is restricted. Surveillance, have a picture about what's going on in the society, how many are infected, how many are not, what's going on. And quarantine the people from Maharashtra to Karnataka or either way, whatever it is, okay? And detect the virus. Maybe on a large scale detection, you have some field level detection, and for confirmation, you should have some like PCR, which is expensive. And also, when people are moving from one place to another, we ask for health certificate. These are all the contingency measures, very well established for human health management and also animal health management. And zoning, like you remember, like we have a red zone, yellow zone, green zone. Instead of saying whole of Karnataka is infected with COVID, there are identified isolated patches in Karnataka which were green till recently, became red in the last few weeks. So you can allow people between the green zones, not branding the whole Karnataka as a red zone. So that way, by zoning, you can have some activity, safer activity. And treatment, what are the treatment? Everyone is looking for treatment for COVID, right from malarial drug to this drug. Nothing is working because it's a virus. Very difficult to come up with a drug for a virus. People don't believe. If at all you have drug for virus, I'm a virologist, trained virologist in North America. If at all you have come up with a virucidal component, it is a nucleoside analogs, starting from HIV, AZT, azithromycin, and what is it, remdesivir, I don't know, funny names. And all these are nucleotide analogs. Okay, they are also affecting the host cells. Okay, it's not easy to come up with a vaccine for the virus. And people are optimistic, searching for the vaccine. Again, it depends on what kind of virus. Do we have a vaccine for HIV yet? How many years old? And particularly for RNA viruses, which are mutating very fast and which are enveloped, still a part of our host membrane, it is difficult to come up with the vaccine, but still people are trying. Let us be optimistic. Okay, these are all the measures we hear and read and about the COVID-19. The same measures holds good for aquatic animals. In fact, it is followed very well in veterinary, like recent bird flu and swine flu. There are many diseases which sudden there is an outburst, and veterinary people, they have a very well established system. They take care of that and bring that to control. The same measures we follow it in aquaculture, and it's very, we were sort of become aware of that from 1994 onwards when white spot virus hit the industry. We culled the crop. Of course, you don't need to cull the crop. The shrimp die en masse anyway. And we went for a crop holiday just to bring down the viral load in nature, because when you go after 3 or 4 crops, that's the purpose of crop holiday. Of course, you have to start afresh with the fresh water, seed, brood, screen, brood with the PCR, so that you can start the business. Okay, so the similar measures, I'm giving a comparison because now everyone knows about biosecurity measures because of the COVID. I thought it's easy to understand now. We'll move on to the next slide, please.
So this is the next slide.
Yeah, this is the next one. Yes, there are 3 levels of biosecurity. When you talk about biosecurity, that one is the farm level biosecurity. The second one is regional and national level biosecurity. The third one is international level biosecurity. Now, what is farm level biosecurity? Farm level biosecurity is very often site specific. It depends on where you are located, your geographical position, inland or inside or coastal or in an isolated place. In all these places, biosecurity measures are different. And also the species you are handling, carp, shrimp, catfish, salmon, trouts, or any other cold water species. It all depends on the species you are handling. So your biosecurity is different. Also, it depends on life stages. What stages you are handling? Is it in hatchery, handling the young ones, or the adults? Because some diseases are very smart. They affect only the young ones. Adults are carriers. You would have heard about some diseases in sea bass, some in trouts. Young ones are affected, adults are carriers. Okay, it depends on the life stages. Operation type, is it an open system or a recirculatory system? And business need, are you going for intermittent cropping or once in a year, or what sort of cropping? Disease, very important, disease profile of the region. In that region, how is that? There are some, what should I say, isolated pockets, even in Karnataka. When there was a white spot virus epidemic, Karnataka, of course, it's not known for large-scale shrimp culture, but there were farms in the coastal areas were affected. But when you move deep into the isolated areas, as seen, farmers were not affected with the white spot virus. So disease profile of a region is very, very important for the farm level biosecurity, and also the kind of host you are managing. Do you have a native species? Do you have exotic species? How they can be managed? Because each one